Okay, so today we're going to discuss a little bit about quadratic functions and models. This will be a short video, and I'll maybe do a couple more parts, or I may just have this lengthy video and you can decide where you want to stop and whatnot. Okay, so let's begin. Okay, so something like f of x equals ax squared plus bx plus c. Now that is called a quadratic function, and we need to let a, b, and c be real numbers with a not being able to equal 0. So this is the function that we represent a quadratic function by. So the graph quadratic function is a special type of U-shaped curve called a parabola. Parabolas occur in many real-life applications, especially those involving reflexive properties of satellite dishes and flashlight reflectors. You will study these properties soon. So all parabolas are symmetric with respect to a line called the axis of symmetry, or simply the axis of the parabola. The point where the axis intersects the parabola is the vertex of the parabola, shown as we're going to be able to see. If the leading coefficient is positive, the graph of so let's go ahead and start discussing these properties. So we'll have a line there, a line here. Okay, so basically this is when the leading coefficient is positive, and this is when the leading coefficient is negative. So the leading coefficient can be basically, so it'd be, again, f of x equals ax squared plus bx plus c, and this one would be where a is greater than 0, and this one would be where a is less than 0. So we've got those. So let's go ahead and begin. Take notes as you go through this. It'll be very helpful. So then again, I'll just really quickly do this. This is called the minimum of a graph. Right here, the lowest point is the minimum, and then the highest point for graphs like these is called the maximum. Alright, so in these, the leading coefficient is positive, and of course this is positive, and then this is negative. So we've basically gotten that cleared up. Okay, so strengths and stretches. Basically, when so I'm going to draw the graph really quickly. And so we have these two. This one is obviously more smaller in the width, and this is greater in the width. So, but this one is called when we shrunk it. I know it looks like we would have stretched it, but it's really when we shrunk it. So we can go ahead and write that back down. So this is shrinking. This is stretch. Now, the graph of this looks like y equals 1/3 x squared. And notice how we have a 1/3 here. You would think that it would, stretch, but it really shrinks. This shrinks. This is obviously shrinking. And then y equals 2x squared is when it stretches. So these are the two graphs of what they look like. Take notes, refer to them. This is all from a book that I get, so it's really great. Okay. So I hope you guys all know how to shift graphs, but if you don't, we'll do one example really quickly if you don't quite remember. So we have y equals x plus 1 minus 2. Let's go ahead and do that. Let's draw these really quickly. Okay, so now remember, what do we do? Just think about, what do we do when we have a plus 1? Well, we move to the left, we always switch, if it's in the parentheses, we always switch the terms. So this would be really, this would be -1, and then this is just, we just leave this because it's not in the parentheses. The vertex would be -1, comma -2, so -1 down 2 here, okay. So -1, 2. So that's where the vertex would be. Then we'd know that this would go up, but this is a very bad parabola, but you get the point. Okay. The standard form of a quadratic function is f of x equals a times x minus h squared plus k. Okay? So that's basically where a cannot equal 0, otherwise the whole parabola is ruined. So we've got that. So sketch the graph of f of x equals 2x squared plus 8x plus 7, and identify the vertex and the axis of the parabola. So let's begin by let me shrink the size down of this. We'll just, so we have our 2x squared plus 8x plus 7, so let me just write that f of x plus 2x squared plus 8x plus 7. Now let's start working this out. So what we do is we do equals, we just kind of take out the f of x, we do 2 times x squared plus 4x, and then we do plus 7, because we needed to take, obviously, this term out right here. So since we do that, after we do 4, then we have to take this middle term right here, we have to divide it by 2, so we do times 1/2, which equals 2, and then we do square, which is 4, right? So you do plus 4, and then we do the 2 times the 4, because we need to add it to this number right here, right? So we do 2 times 4, which is 8, but then you have to change the signs of this, so it would really be minus 8, correct? Okay, so we have that plus that minus 8. So then our final quadratic function would be 2 times x plus 2 squared plus 1. Or excuse me, minus 1. Okay, minus 1. Okay, so that's what we got over here. Alright, one example, basically that's it. If you can do that, then you can, oh, did we forgot to do the axis of the parabola. So the axis of symmetry would, so our vertex, what's our vertex in here? So we got -2, comma, -1. So our axis of symmetry would be x equals -2. Okay. Right. I think that should be it for today. We've basically got everything covered, and hopefully you understood everything. Check out my other vids. Bye.